This video, we're going to be looking at an introduction to complex numbers. Now, complex numbers are numbers that have an imaginary number. You've heard me say time and time again, there are real numbers and there are unreal numbers. And I told you that eventually we would talk about what are unreal numbers, aka imaginary numbers. An imaginary number is represented with an I. This is the square root of -1. The reason why this is imaginary is because when you take a square root of a number, you cannot take a square root of a negative number until now with our imaginary numbers. So if I equals the square root of -1, I squared is going to equal -1 without the square root. And that makes sense. So from this, there are different operations that we can use with imaginary numbers. A complex number is in the form of A plus BI. Okay, so with that, we're going to be doing adding and subtracting of complex numbers, multiplying, dividing, that kind of thing. So for example, if I were to have 3 minus I plus 6 plus 4i. When you're adding complex numbers, it's kind of like when you're dealing with regular polynomials and you're combining your like terms. When you're adding and subtracting those complex numbers, it's the same concept. I have a 3 and a 6, and I have a -I and a 4i. So these are my like terms. I'm going to combine them with addition. So I have 3 plus 6 to give me 9. -I plus 4i gives me a positive 3i. So right there, I just added my complex numbers just by combining my like terms. Same concept with subtraction. If I were to have 10 minus 6i minus, let's go with 5 minus 4i. Okay, again, looking for my like terms. The difference, though, is you have a subtraction sign in the middle, so don't forget about that. So it's 10 minus 5 to give me a 5, -6i minus -4i. Okay, so that's really -6 plus 4i. So I have minus 2i. So adding and subtracting complex numbers, fairly straightforward, just combine your like terms. Multiplication. So let's say that we have 3 plus 2i. We'll start small for right now, times 4i. This is just your distribution. So 3 times 4i gives me 12i. 2i times 4i gives me positive 8i squared. So this is where we have to take note, remember that I squared equals -1. So this is really 12i plus 8 times -1. Final answer is 12i minus 8. Okay. Division. Before we actually get to division, we have one more thing to talk about. A complex conjugate. A complex conjugate are complex numbers with equivalent real parts and opposite imaginary parts. So it's almost easier if I just give you an example. If I were to have 3 minus 2i, the complex conjugate is going to be 3 plus 2i. So the sign in front of the I switches or goes to the opposite. And it has to be the sign in front of the I. Sometimes the I might be listed first, so you're going to have to use that negative or positive in front of the I term, okay? So when we have division, so let's say that I have 4 over 6 minus I. When you have division, you are going to multiply the numerator and the denominator by the complex conjugate. So I'm really going to multiply the top and the bottom by that 6 plus I. If I'm thinking about this, why can I just do that? I can do that though because I have in the green there that 6 plus I over 6 plus I. That's the same thing as 1 over 1. So in mathematics, that's not saying that we're changing anything because we're multiplying by 1, realistically. But we all know that technically with multiplication, things are going to change a little bit. So we're going to go ahead and multiply. Looking at just the top, I'm going to have 24 plus 4i. On the bottom with my distribution, I'll have 6 times 6 to give me 36. 6 times positive I. Now that negative I gets distributed. And then I have negative I times positive I. So if I look at my denominator here, there's some things that happen when I multiply by the complex conjugate. The i's happen to cancel out because, remember, I squared equals negative 1. So now we have 24 plus 4i over 36 minus negative 1, which is going to give me 24 plus 4i over 37. Now, there's one last thing. How does this tie into quadratics? This ties into our quadratics because we are going to solve quadratics using complex solutions. So, for instance, if I were to have 9x squared plus 16 equals 0. Okay, so I want to factor this. I'm going to have to look at how the first term and the last term are perfect squares. Because they are perfect squares with addition, this is going to be in the form of a squared minus negative b squared. Okay, so what that means is we're taking the square root of both of these. Okay, when we're taking the square root of both of these, what's actually going to end up happening is we're going to end up with a negative in the form of a plus bi times a minus bi. Okay, so this is just a complex number multiplied, complex conjugates multiplied together in order to get that 9x squared plus 16. This only works if you have perfect squares for the first term and the last term. So in order to find my a, I'm going to take the square root of 9x squared. The square root of this is going to give me 3x. Now the b. I know it looks like that it's a positive 16, but because of this double negative here, we actually have the square root of negative 16 because of that negative there. Well, the square root of a negative 16 is going to be 4i. Square root of 16 just gives me the 4. We have the negative underneath the square root, which is going to give me the I. So our factored form is going to be 3x plus 4i, 3x minus 4i. And that's going to equal 0. So I could go through and solve this and set each factor set to 0. Move our information over. So one of my x's is negative 4i over 3. And this x over here is going to be a positive 4i over 3. So depending on what you're wanting, if you're just wanting the factors or if you're wanting the actual solutions. Okay, so these are complex numbers. We're going to be working with these a little bit more intensely when we get to some other types of quadratics. But again, an I represents an imaginary number, which is the square root of negative 1. I squared equals negative 1.